First thing we're going to do on 7.4 is we're just going to review all the types of graphs that we've learned this year, okay? We're going to just talk about them briefly, talk about what shape that they are, okay? And hopefully some of this starts coming back to us. So, first one is what we call a constant. What does a constant look like? Okay. It's a straight line. What kind of straight line, though? There's something about it. It's a straight, maybe once I start writing it, you'll know. Yeah, straight horizontal line, okay? It is a straight horizontal line. It's got a slope of 0. Okay, that's what a constant is. Next up, we have a quadratic. This was one of the first things we graphed in this class. What did a quadratic look like? Yeah, it made a U shape. Good, okay? It makes a U shape, whether it's right side up or upside down, okay? It's going to make a U shape. One other thing that's important to know about quadratics, when you see the equations, they have a degree of 2. What do I mean when I say degree?
You know what I mean.
I know what you mean, but I need the word for it.
It's the square.
The exponent, right? Okay, so if it's got a degree of 2, that means the highest exponent in that problem is a 2. And typically that's going to be the leading one, okay? Then we have what's called a quartic. We kind of briefly discussed this word when we talked about just like sketching our graphs when we did the arrows, and then we did whether it crossed the x-axis or it bounced it, okay? These have a degree of 4. So 4 is their highest exponent. And then these are going to make either like a W shape if they're going up, or maybe like an M shape. Means a degree of 4. Typically that's what they look like. Not always, but typically. Okay, and then we get into cube roots. Again, these are all mixed up, so these aren't going in the same order that we learned them. Cube roots. So when we talked about roots, if it was a cube root, that meant it had a degree of
3.
Close. So it wouldn't be 3, because that would be a polynomial.
6.
What about 1/3?
Oh, that makes sense.
Yeah, because it's a root, okay? So typically we'd see something in parentheses taken to the 1/3 power, or we would just see this cube root symbol, okay? That was how we figured out it was a cube root. And then really the best way to describe the graph of these, it sounds childish, but it's just kind of like a horizontal squiggle, horizontal squiggly line, okay? So it's going to have a little bit, just a little kind of wave there, but those arrows are going to stay horizontal from left to right. They're not going to go vertical. They're going to stay horizontal. Okay, exponential. This was one of the more recent things that we talked about. What did an exponential look like? What'd you say? Yeah. So kind of like it grew, right? We called that exponential growth. Okay. Could we also have it going the opposite way, like going down? Exponential decay. Good. Okay. One other thing about these is that they have what's called an asymptote. What kind? Would it be a horizontal or a vertical? It would actually be horizontal. Okay, because they're going to get really close to that line. So I'm just going to put HA over here. If you need to write out horizontal asymptote, do it. Okay?
I don't know how to spell it, so.
That's okay. I'm not grading you on your spelling. Okay, any questions on those first 5? No, we good? Okay. Next up, we have linear. We've been talking about these since like 8th grade or maybe 7th grade. Okay? What are these? What'd you say? Yeah, just a line, a straight line, okay? But it's going to have some slope to it. It's going to have some slope to it. So whether it's positive or negative, it doesn't really matter. But it is going to be a straight line, a little bit of slope. Or a lot of it. You got it. Okay. Then we get to what we call cubic functions. These have a degree of, what do you think? Cubic. We already did 1/3. That was cube root. 3. It's going to be a degree of 3. Okay, and if we notice, degree of 1/3, degree of 3, those are inverses, which kind of makes sense because a cube root and a cubic probably should be inverses, right? Okay, and these are going to look very similar to the cube root, so don't get them confused. However, instead of being a horizontal squiggle, it's going to be a little more vertical, or a lot more vertical. Okay, so what these look like is they've got that same wavy shape, but those arrows are going to be pointing up and down. So that is a cubic. Okay, then we get into a square root. These have a degree of half. Thank you. Yep. Square root. And what would their inverse be? What would a square root's inverse be? Yeah, quadratic, because these have a degree of 2. Okay, cool. And a square root function, what do those look like? How do I spot those? Okay, they look like a square root. Well, I mean, in the equation, yeah, we could have a square root symbol, but I'm talking about their graphs. Okay, if you can remember the graphs of these, so like here's my quadrants, they actually would have like a starting point, and then they would either shoot up or down to the right, okay? So something like this. Okay, so the key thing here is that these had a starting point, so you might want to write that. They're the only ones that did. Okay. Next up, we have what we call rationals. That was this semester as well. What do we know about rationals? What is a rational? Synonym. Yeah, it's a fraction. Okay. So these problems are going to look like fractions. But they're graphs. We said that they kind of look like opposite quadrant graphs. It was okay if they kind of went in multiple quadrants, but they looked like this. They had 2 graphs that were going the opposite ways. Okay, we also called them hyperbolas. There's just another fancy word for that. You'll talk about that in a college algebra if you're headed there. And then last but not least, a logarithmic. Okay, or log. What did these look like?
I can't remember.
What was this one's inverse? What did we learn whenever we learn logs? We graphed 2 things at unit. It's on here.
It's been a while.
Exponential. Okay, let's wake our brains up. Yep, exponentials are the inverse of logs. Please don't forget that, okay? And what these look like. So instead of having a horizontal asymptote, these are going to have a vertical one, okay? And they're going to be kind of like this, okay? Or maybe they even shoot down. Okay, that is what a logarithmic is. Do not forget that logs and exponentials are inverses. Okay, so on the next 2 pages, there's 8 graphs on the first, and there are 6 graphs on the second. I want you to use this as a word bank, and I want you to go classify those. Okay, I'm going to give you like 2 minutes. Ready, set, go. All right, let's start over on the far side. Zoe, what'd you get for this first one? Exponential. Do we agree with her? We should. She's right. Okay. Would you call this exponential growth or decay? Decay. Okay, because it is going down from left to right. Good deal. Good deal. Okay, next table. Cade, what'd you got for this one? What'd you say?
Quadratic.
Different Q word.
Court.
Quartic. Yep, this one would be quartic. Okay. You're okay. You're okay. So this one would be quartic. If you look, it goes through here, bounces here, goes through here. If we added that up, that would end up being a degree of 4. Okay. Cool. Next one. Bodie, what you got for this? Constant. Good deal. Constant is just a line that's got no slope. Horizontal. Okay, next table. Kyle, what'd you get for this one? Kyle. What'd you get for this one? Nate, can you help him out? Oh. Cube root? I don't know if I agree with you. Nate, what'd you put for this one?
Square root.
Square root. Good. Okay, it should be a square root. You were close, Kyle. I'll give you that. Okay, it was a root. But this one, how do we know the difference between a square root and a cube root? Yes, Riley?
The square root has a starting point.
Yes, square root has a starting point. We can see this one just kind of starts out of thin air, okay? That's why it's a square root. All right, this one, Cadence, what you got?
Log.
Log, good deal. This one is a log. Okay. Travis, what'd you get for this one? Cube root, good deal. Horizontal squiggle. Okay. Mel, what'd you get for this one? Cubic, good. Okay, vertical squiggle. Zoe's already gone. Brooke, what'd you get for this one? Rational, good. Rational. Okay, how many of you guys were 8 for 8 on that page? Okay, cool. How many of you were 7? Okay. That is going to be on the test. Okay, these will be on the test, so please make sure we know how to do these. Okay. Tristan, what'd you get for this one? Close. Log. It's a log. Okay. This one's a log. Alexis, what'd you get for this one? Cubic. We can see some of them are starting to repeat themselves now. Yep. This one's a cubic, vertical, squiggle. Okay. Miranda, what'd you get for this one? Linear. Good deal. Straight line with some negative slope. We love to see it. Okay. Jack, did you get this one? Quadratic. Good deal. Upside down U shape. Okay. Jacob, what we got for this? Rational. Good. Another rational one. And last but not least, Riley, what you got?
Linear.
Linear. Okay. How we doing that page?
Really good.
Really good? Okay, if that was a test question, we'd do really well on it.
Yep.
Okay, any questions before we move on? Okay, we have 5 graphs that we are graphing today that we've got to get through, okay? Please have Desmos ready to go, okay? Because we're going to be typing these in so that way we don't have to graph them by hand because we don't want to do that anymore, okay? First things first, the absolute value function. This is the only one we haven't talked about yet, okay? And I don't know why it wasn't in our last activity, but it wasn't, okay? This was one of the first things we graphed. What did these look like? What shape did they look like?
What was it again?
An absolute value. So if a quadratic looked like a U, we did this the same unit. Quadratics look like U's and absolute values look like V's. Yep, they made a V shape, okay? They made a V shape. And actually, their domain and range, which are going to be important in this unit, their domain range worked the same as a quadratic. So domain went from negative infinity, positive infinity, because we went left and right forever. And then range either went from negative infinity to your K value or from your K value to positive infinity. Okay, and you hopefully recognize that letter K. Maybe you'll recognize it if I put it like this, H comma K. You remember that? Okay, that was typically our vertex for pretty much everything we graphed, okay, or our starting point we just used h comma k. H for the x, k for the y. Okay, so write that down somewhere. Then we get into square root functions. Already talked about these. We said these have a starting point, okay? So depending on where that starting point is, that's going to affect your domain and range. So domain is going to go from the x value of that starting point to positive infinity, because we're always shooting to the right, typically on these. And then range, again, is going to depend on whether you're shooting up or down, negative infinity to k, or k to infinity. And then cube root functions, we said these were the horizontal squiggles, kind of, right? Okay, and if we look at any horizontal squiggly line like that and put it on a graph, we're going to realize that goes left and right forever. It also goes down and up forever. So little refresh on domain range, because that is important. That will be a grade on all of these. Okay. So, hopping on down. Graph 1 out of 5 that we're graphing today is this guy right here, okay? When you go to type this into Desmos, there is absolutely no reason to type f of x equals, okay? You don't need to type that. You literally just need to type what is on the opposite side of the equal sign. Everything's on one side already, okay? So go type this in. If you struggle to find how to type in these absolute value bars, don't type in like the number 1 or something stupid, okay? On that very front keyboard of Desmos, there is a button over to the left-hand side. It's like 3 rows down, and it looks like this. It's got absolute value bars around a lowercase a, okay? That is the button you are using. So I want you to go plug this in, see what it looks like. I'd click on it and get some points and put those points on this graph. So take about a minute or two to do that real quick. Okay, give me some points that you put on this. 0, 0. Good.
4, 0.
4, 0.
2,
And 2, -6. Okay, can we graph it with just those 3 points? We sure can, but if you put more than that, that's fine, okay? You put however many you need to graph this thing. You obviously need more than one, though. Okay, so we graph it. It's not perfect. It's not the most beautiful thing ever, but there it is. Okay, yours should look very similar to mine. And then we go and we answer these questions. So the first one here, I'm going to help you with these. Okay, so we'll start at the top. Domain. You have a question?
Yeah.
What's your question?
Can you find domain range on these?
Can you find it? I mean, you can look at it, yeah, but you have to know what domain and range are. It's not just going to tell you. Okay, good question. Domain range. So domain is left to right. What's this thing doing? Negative infinity, positive infinity. Good deal. Range, bottom to top. Good. -6, positive infinity. You've got to use the y value. Don't use the x value for range. Okay? When we learned absolute values, had we even learned anything about asymptotes or holes yet? We hadn't. Okay? So these are definitely not going to have those. Okay? Limits. Limits. For the x values of my limits, I always copy the domain. So as x goes to negative infinity and positive infinity, left and right. And then I'm telling what y is doing. So as x goes to the left forever, y is going positive infinity. It's going up. Okay, y only cares about up or down. It doesn't care about left or right. Okay. As x goes to the right forever, y is going, it's going up again. Yep, positive infinity. Okay, would this have a max or min point? Yes, which one? It would have a minimum. What is it? Okay, it's a coordinate point though. 2, -6. Okay, and then it would not have a maximum. Remember, infinity is not a point. Okay, so you cannot put that for a maximum or a minimum. Okay, the next thing, this is the most missed thing on this test right here, okay, is increasing, decreasing intervals. So you just told me that we had a max or min, right? Okay, so what you told me then essentially is that we are changing direction at that point. Okay, so that means here I could basically draw kind of just an invisible line. This is not an asymptote. I'm just drawing a line through here. And what x value is that line going through? It's going through 2. Okay, so I could break this graph into pieces here based on where my turning points are. Okay, and that's going to give me what my intervals are. Okay, so if we look, if this was a roller coaster, I know you're tired of hearing me say that, okay? But if this was a roller coaster from the left to the right, what would it be doing first? Decreasing and then increasing. So we're going to have one of each interval, okay? And it's going to change directions at 2. Because again, when we're writing intervals, we're writing the domain or the pathway on x, okay, that we are increasing or decreasing. So if I'm writing the x values, I know that my domain goes left and right forever, so I could label that 2, okay? And you just said we are decreasing first. So from negative infinity to positive 2, I'm decreasing. From positive 2 to positive infinity, I'm increasing. Are we clear on that?
Yes, ma'am.
Don't ever put like 2 to negative infinity as any type of interval because you're never going to go to the right to negative infinity. Okay, I see that a lot. Please don't do that. Okay, and then last but not least, x and y intercepts are so easy with Desmos. You don't have to do any math. You don't have to go plug in 0 for the opposite letter. Okay, you literally just go and click on where this crosses. So for x intercept, what do we got? 0, 0. Yep, and 4, 0. We had 2. Good, and then what about the y-intercept? 0, 0. Perfect. Any questions on this first graph? No? Okay. We're skipping the second one. We're going on to the first square root function. The first square root function. So you are going on Desmos. Quickly, go type in this side of the equation. There is a square root button on the very front keyboard. You don't have to click on anything to get it. It just looks like this. That's what you're using. Make sure you don't forget the negative in the front. Okay, go type that in. All right, what points do we put on this?
First, up 4 with 2.
Okay, so over 2, up 4, you mean? So 2, 4.
Yeah, 2.
Okay, so that was the starting point. Yeah, we definitely need that point. Okay. How many more points did you put on this?
6, 2.
Okay, so you put 6, 2. Do we think that's probably enough?
Yeah.
Yeah, probably. You can probably get the general shape with just that. Okay? Give you about 2 minutes. Go through, work with your group. Fill in these blanks to the best of your ability. Okay, ready, set, go. Domain on this one is what? Left to right, left to right. What we got?
2 to infinity.
2 to positive infinity. Good. Range, bottom to top. Careful. Bottom to top. What do we think? Negative infinity to 4. Okay, the y value. Got to make sure for range we put y values. Okay? Asymptotes or holes, do we think these have any? No, they do not. Okay? Limits, I should copy my x values, which are, or my domain. What did we just say the domain was? Help me out, guys. Come on. 2 to infinity. Good. Okay, so as x goes to the left to 2, where's y going? Is it going to infinity as x goes left? If I trace this thing to the left, what's y doing? It's stopping right here. At what? 4. Okay. It's stopping at 4. Okay. And then what about as x goes to the right forever? Y is going... It is going to negative infinity. Okay, good. Max or min points? Does it have one? Technically, I guess you could call 2, 4 a max. Technically, we don't really change direction there, but we could still call it that. It doesn't have a min. Increasing, decreasing, what do we think? The whole thing is decreasing, so I should just copy the domain, which is,
Two,
okay? And then x and y intercepts, these should be pretty easy. Go back to Desmos, click on where we cross. What do we get for x? 18, 0. And what about y? There's not one. Okay, it's not going to cross the y-axis. It's going to the right. Okay, any questions on this one?
Nope.
Okay, next one. We are skipping that top problem. We're going down to the first cube root problem. Okay, how we type this in. There's a lot of confusion on our 7A test about how to type in a cube root. So go to Desmos right now. Okay, you need to hit the functions button. And then you're going to scroll all the way down to that very last category. I think it says like number theory or something like that. Okay, and there is going to be a button. There's going to be a button that looks like this. Okay, it's got, does it have a lowercase? I don't know what. It's a lowercase n. Yep, a lowercase n. And then it's got this symbol. Okay, it looks just like that. That's what you're using to type in a cube root, okay, or any root that's bigger than a square root. So go find that button, go type this in, and put it on your graph. All right, what points did we use? There's plenty of them. What'd you use? 0, -1. 0, -1. 7, 0. -1, -2. I like it. What'd you say? -9, -4. Okay. Did anybody use -2, -3? Yeah. Okay. You might not need this many. It just totally is up to you. However many you need to make sure you have the right shape. Okay, but this is probably a good number. And that is the shape you should have. Okay. Give you about 2 minutes. I want you to go fill in these blanks to the best of your ability. Ready, set, go. Domain for this one is what? Good. It's going left forever, right forever. What about the range? Same thing. Bottom forever, or down forever, up forever. Okay. Asymptotes or holes? No, no, no. Okay. Limits. I should copy what for the x's? Domain. And then as x goes left forever, y is going... It's going to negative infinity. It's going down forever. Okay, and as x goes right forever, y is going up or down? Up. So positive infinity. Okay. Will this have a max or min? No, it will not. Okay, because we're not changing direction. Okay. And then what about our interval? The whole thing is increasing? Yeah, because we're not changing direction. Okay. So hopefully you just copied the domain. Again, we never copy the range. Just so happened that they were the same on this one. And then x and y intercepts, what do we think? 0, -1 for x. For y, I would agree. And 7, 0 for x. Okay? Be really careful on those because I will count those wrong on the test if you flip-flop the numbers. So don't put, like for the x-intercept, don't put 0, 7. Okay? Because that will be wrong. That's not a point that's on this. Okay? Any questions before we move on? Okay. We are skipping the next problem, and we are headed to 7.5, okay? Just because we're skipping around, we're trying to get through some of this stuff quickly because it's not that hard and we've done it before, okay? Quadratic functions. Real quick. We already said that these are U-shape, okay? We already said that they're U-shape. Another synonym for these is the word parabola, if you want to write that down, but you don't have to, okay? Quadratic. So, domain and range, it's going to be the same as the absolute value. Okay, we said that already. So negative infinity, positive infinity for domain, negative infinity to k, or k to infinity, depending on if this thing's going up or down. Okay, and then we have what we call polynomial functions. So these look like my factoring problems because they are. Okay, we factored polynomials. Okay, and the graphs are going to depend on the degree. And we said degree just means the highest exponent, right? Okay, so for instance here, if the degree was 2, we just said that's a quadratic. If the degree was 3, we called that a cubic. Good. And then what about 4? Quartic. Yep. Quartic. Okay. And those would keep going because you can have polynomials that have a degree of 5, 6, 7, and all the way up to a billion. Okay. However, these are just the ones that we're going to see in Algebra 2, are 2, 3, and 4. Okay. So quickly, go type this into Desmos. Go put this on a graph. Okay. Quickly. Should not take long. What points did we use? 3, 2, good. Definitely need that one.
4.4.
Okay. 4.40 and 1.50, 1.60. Okay. That's probably enough, isn't it? Whoops. If you put more though, that's okay. Okay, it should just be an upside down U. All right, and let's quickly go through these blanks together. What's the domain for this? Yes, negative infinity, positive infinity. The range? Negative infinity to 2, good. Do we have asymptotes or holes? Nope. Okay, limits, we're gonna copy the domain for the x's. As x goes to the left forever, what's y doing? Going down. And what about as x goes right? Same thing, okay. Does this have a max or a min point? It does have a max. What is it? 3, 2. No minimum. Okay. Increasing, decreasing. Take a second. Talk this out with your group right now. Okay? Take a second. What do we think this is going to be? Talk. Not to me. Talk to your group. Don't stop looking at me.
Degree.
Okay, what do we think?
I like, well, negative infinity.
Negative infinity
The
for the first one, 2
3.
to 3. Do we agree with Riley? Yes, we should. Okay, you're telling me the x value, so that's good. We're increasing from negative infinity to 3. Yep. And then what about decreasing? 3 to infinity. Good deal. 3 to positive infinity. Good. What questions do we have? Okay. X and Y intercepts. Quickly. What we got?
1.5860.
Okay. Could you round it?
1.5.
I think it'd be 1.6, wouldn't it?
Oh, yeah.
Okay. 1.60 and...
4.4.
Okay, and then what about the Y intercept?
It's like a big.
-7. Okay. So my graph really should have been a little wider. Oops. Okay. Just like that. Okay. Either way. All right. Any questions on that? No? Last one. The next page I want you to go to example 5. We're skipping quite a few, but go back to these other ones if you want more practice, okay? All right. Quickly. You know the drill. Go type this baby into Desmos. Put it on the graph. How we doing?
Good enough.
Good enough? Okay. This one looked kind of crazy, didn't it? A little bit. We remember graphing these? Yeah? Okay. Give me some points on this thing. -4, 0. -1, 0. 2, 0. 0, -8. Okay. Good. I'm gonna actually write that one in here just so I can see what it is. Okay.
You wrote on -1.
Say what? No, you're good. You're good. Okay, negative 2.7, 10.3, or 10.4 maybe. Okay. Do we think that's probably enough? Yeah, let's just kind of connect the dots here. That's kind of what we have to do. It doesn't have to be the most beautiful thing. As long as it follows the general shape and you have your points in the right place, you should be good. Okay. How many of us got that? Okay, did anybody get something super weird when they typed that in that didn't look like this? Okay. No? All right. Give you about 2 minutes to the best of your ability. Fill in those blanks, and then we will call it a day. I'll let you spend the rest of the time to do your homework. Domain for this one is what? Negative infinity, positive infinity. What about the range? Also negative infinity, positive infinity. Do we have asymptotes or holes? Nope. Limits. As x goes to the left forever, what's y doing? It's going... Yeah, it's going to negative infinity. Okay. And as x goes to the right forever, y is going positive infinity, right? Okay. Then we get to our extrema, our max and min points. Ooh, what do we think here?
I did 2.7 instead of 0.7.
Okay, so you use those points.
Yeah.
So your max was negative 2.7, 10.4, and your min was 0.7, negative 10.4.
Yep.
Do we all agree with those? Okay, that is correct. And then we get to our intervals. This is where it gets a little more tricky. This was probably the most missed question, or the most missed part of this question on the test last year, okay? Was increasing, decreasing intervals. So before we write these down, let's just talk. Where are we changing direction here? From left to right if this was a roller coaster. Where are we switching from increasing to decreasing? Negative 2.7 and 0.7. So those are the numbers that you should have in your intervals, those x values, okay? And if we already talked about the domain was negative infinity, positive infinity, right? So that means left forever, right forever. So we also need those numbers in our interval. Okay, so hopefully that kind of helps. And even if you need to like take a highlighter and kind of just break this into pieces so you can see, okay, I'm increasing, then I'm decreasing, then I'm increasing again, okay? That might help. Okay, so help me out. First interval, from what to what? What am I doing?
Negative infinity to 2.
Okay, so negative infinity to negative 2.7, we are increasing or decreasing?
Increasing.
Increasing, good.
And then go from negative 2.7 to 0.7.
We're decreasing there,
Yep.
okay?
And then go from 0.7 to infinity.
Perfect, that is perfection. Write that down. Do we have questions about that? No? Did anybody get that before I did? Okay, good, good, good. If you didn't, make sure you study that. And then last but not least, the x and y intercepts, those should be pretty easy on Desmos, just a click.
Yeah.
0, negative 8 is the y-intercept. Okay, and then what about x?
4, 0, negative 4, 0, negative 1, 0, 2, 0.
Okay, we had 3.
Yeah.
Okay,
That's how we know.
that's how we do it.
It has a degree of 4.
Okay, your homework is up there on the board. Numbers 1 through 6, 11 through 14, 31 through 34. 1 through 6 and 11 through 14, you literally just have to type it in a Desmos and put it on a graph. You don't have to answer any questions about it, okay? 31 through 34 you do. So, get to work. You got a little bit of time left.